welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward the Kuiper Belt, that immense and frozen ring of ancient remnants, shadowing the darkest edges of our solar system. Beyond the blue majesty of Neptune lies a domain where the sun is reduced to a brilliant point of light, casting faint shadows across worlds made of rock and ice. This is the true frontier of our planetary neighborhood, a vast cosmic ring road that holds the unblemished history of our origins. As we slip past the final gas giant, the noise of the inner worlds fades away into a profound, velvety quiet. We enter a space where time seems to stretch and slow, inviting our awareness to expand into the cold, beautiful emptiness. This icy wasteland spans billions of miles through the dark, forming a monumental disk of primordial material that has remained largely unaltered for more than 4 billion years. Unlike the rocky debris found closer to the sun, the objects here are rich in volatile ices like methane, ammonia, and water, preserved in a perpetual deep freeze. It is a realm of quiet giants and countless smaller fragments, all moving in slow, stately orbits that take centuries to complete a single journey around the distant sun. We can imagine these dark, icy bodies drifting through the void, completely isolated from one another by distances that defy ordinary human comprehension. There is a deep, architectural elegance to this arrangement, a testament to the orderly forces of gravity that shape the outer architecture of our stellar home. To contemplate this space is to appreciate the sheer scale of the solitude that envelops our world. Within this silent repository lies the mysterious cradle of short-period comets, those luminous travelers that occasionally grace our inner skis with their ethereal glows. For millions of years, these icy relics drift in perfect obscurity, acting as time capsules from the very dawn of creation. Every now and then, a subtle gravitational tug from a passing body or a subtle interaction with Neptune alters the trajectory of one of these frozen wanderers. This gentle nudge initiates a journey lasting hundreds of years, pulling the ice world out of its dark home and sending it plunging toward the warmth of the inner sun. As it approaches the light, the ancient ice begins to melt and turn directly into gas, creating the magnificent, glowing tales that have captivated humanity for generations. In this way, the dark wasteland of the outer system directly connects to the vibrant history of our own planet, reminding us that even the most distant corners of space are intimately bound to our existence. As we begin our detailed immersion into this frozen wilderness, we prepare to uncover the secrets of 100 distinct truths hidden within the ice. Each revelation offers a window into how the planets formed, how water may have been delivered to a young Earth, and what lies at the very boundary of interstellar space. The air is still, the mind is clear, and the vast expanse of the Kuiper Belt opens up before us like a map of ancient time. Let yourself drift effortlessly into this grand, dark theater of astrophysics, where every frozen particle tells a story of cosmic patience. The journey ahead is long, peaceful, and filled with the quiet wonder of a universe that breathes in centuries. The journey into this remote wilderness begins with the realization that human minds foresaw this dark ring long, before telescopes could ever glimpse its individual members. In the mid-20th century, dedicated astronomers suggested that the edge of our planetary system could not simply be an empty void, but must hold a reservoir of ancient icy materials left over from creation. They reasoned that the material at such extreme distances would have been too sparse and spread out to coalesce into a massive, singular planet. Instead, a vast band of smaller, frozen fragments remained scattered across the dark, waiting in silent isolation for billions of years. This brilliant hypothesis transformed our understanding of the solar system, revealing that the apparent edge was actually a crowded threshold of ancient history. We now recognize this immense region as a monument to scientific intuition, a place where the ghostly remnants of the early solar nebula still drift in the cold. To comprehend the true scale of this frozen landscape, we must measure the immense distances that separate these quiet wanderers from the warmth of our central star. The inner boundary of this cold domain begins just past the orbit of Neptune, roughly 30 times the distance between the Earth and the Sun. From that threshold, the massive ring of ice stretches outward into the deep unknown, expanding across space until it reaches about 50 times our orbital distance. This means the sheer width of the frozen belt spans billions of miles of empty space, an expanse so vast that sunlight requires more than 4 hours just to cross the threshold. When we imagine this incredible breadth, our minds expand to accommodate a scale of existence that completely dwarfs our daily lives, inviting a sense of profound stillness. The geometric structure of this distant region resembles a monumental cosmic donut that completely encircles the outer reaches of our solar system. This thick, three-dimensional disk creates a grand protective ring around the inner planets, holding trillions of icy bodies within its wide, graceful embrace. While the inner planets orbit the Sun in a relatively flat and tidy plane, this outer ring exhibits a more complex, cloud-like depth that swells above and below the main orbital track. The sheer volume of this space is almost unimaginable. A massive toroidal cavern of darkness where individual objects are separated by millions of miles of pure vacuum. As we visualize this colossal ring spinning slowly against the backdrop of distant stars, we perceive the mathematical perfection that governs even the coldest, most isolated corners of creation. The ancient objects that dwell within this dark ring are fundamentally different from the rocky and metallic worlds found closer to the heat of the Sun. Because they formed in the deep freeze of the outer nebula, these bodies are composed largely of frozen gases and volatile liquids that turned to solid ice billions of years ago. Thick layers of frozen water, methane, ammonia, and carbon monoxide coat their dark surfaces, creating a unique planetary chemistry that remains perfectly preserved by the intense cold. These chemical compounds are mixed with primordial dust and dark organic matter, giving the objects a dull, dark coloration that helps them blend perfectly into the shadows of space. This composition makes them invaluable to modern science, as they represent the pristine, unbaked ingredients that originally built the core of the giant gas worlds. Despite the staggering number of objects that inhabit this immense outer ring, the total combined mass of all these bodies is surprisingly small. Scientists originally believed that this region must contain a massive amount of matter, but modern satellite observations have revealed a far more delicate reality. If we were to gather every single piece of ice, every dwarf planet, and every tiny fragment within the belt and fuse them together, the resulting world would weigh only a tiny fraction of our planet Earth. This unexpected scarcity of matter tells a fascinating story of the early solar system, suggesting that much of the original material was violently cast out into deep space by the gravitational fury of the giant planets. What remains today is merely a whisper of what once was, a beautiful and sparse collection of cosmic survivors drifting quietly through the dark. Each individual object in this frozen wilderness can be understood as a planetesimal, an ancient building block of a world that never quite came to be. During the chaotic dawn of our solar nebula, these tiny bodies collided and merged to form the foundations of the majestic planets we know today. However, in the distant regions beyond Neptune, the density of material was simply too low, and the time required for objects to find one another was far too great. Before these fragments could assemble into a proper planetary body, the energetic winds of the young sun cleared away the remaining gas, freezing the growth of these objects forever. They remain frozen in a state of perpetual childhood, a vast collection of unfinished pieces that allow us to glimpse the raw materials of planetary creation. The environment within this remote ring is defined by a level of cold that is almost impossible to replicate or experience within the warm atmosphere of Earth. Temperatures here hover just a few tens of degrees above absolute zero, the theoretical point where all molecular motion completely ceases to exist. At this extreme level of chill, chemical reactions become entirely frozen in time, preventing the objects from changing or degrading over the course of billions of years. This absolute freeze acts as a perfect cosmic vault, protecting the ancient surfaces from the erosion and heat that continuously reshape the inner planets. To contemplate this environment is to imagine a world of perfect preservation, a silent museum of ice where the past is locked away in a pristine, untouchable sanctuary. The darkness that blankets this distant region is incredibly deep, transforming our brilliant sun into nothing more than an exceptionally bright star in the velvety sky. At these immense distances, the sunlight is thousands of times fainter than what we experience on a clear afternoon on Earth, providing no perceptible warmth to the frozen worlds below. If you were to stand on the surface of one of these icy objects, the sky would appear completely black even at high noon, with the distant stars remaining visible throughout the entire day. This permanent twilight creates a landscape of soft shadows and faint illumination, where the features of the ice are only dimly revealed by the cold starlight. It is a world removed from the energetic rhythms of day and night, existing instead in a state of eternal, serene evening. Time moves in a completely different rhythm out here in the frozen dark, governed by orbits that require centuries of human time to complete a single circuit around the sun. While the Earth rushes around our star in just 12 months, an object in this outer ring may take nearly 300 Earth years just to finish one solitary journey. This means that since the dawn of modern human astronomy, many of these remote worlds have not even completed a fraction of their grand orbital paths. This incredibly slow movement creates a sense of profound patience, as if the outer solar system operates on a geological and cosmic timeline that ignores our brief human lives. Watching these bodies drift through their long, centuries-long arcs inspires a deep feeling of tranquility, reminding us of the steady, unhurried pace of the cosmos. As scientists peer deeper into this silent wilderness, they have discovered that the icy bodies are organized into distinct families based on how they interact with the gravity of Neptune. One major group exists in a state of perfect independence, occupying stable, nearly circular paths that have remained completely undisturbed since the beginning of time. Another fascinating family of objects is locked in a precise gravitational dance with the giant blue planet, their orbits perfectly synchronized in a mathematical harmony that prevents them from ever colliding. This delicate structural division reveals that even in this seemingly chaotic and abandoned wasteland, the unseen hand of gravity maintains a beautiful, rhythmic order. The entire region is a masterpiece of celestial mechanics, a quiet symphony of orbits where every frozen fragment has found its perfect, destined place in the dark. The historic uncovering of the first major citizen of this distant realm fundamentally altered our perception of the outer solar system, long before we understood the true nature of the belt itself. For decades, this lone world was thought to be an isolated oddity, a small, freezing planet tracing a tilted and eccentric path through the dark outer dark. It was only when modern technology allowed us to peer deeper into the void that we realized this world was not a solitary wanderer, but rather the largest and brightest representative of a vast, hidden collective. This realization shifted our entire cosmic perspective, transforming a supposed planetary outcast into the proud pioneer of an entirely new geological frontier. Today, we look at this famous icy body with a sense of reverence, recognizing it as the gateway to the magnificent expanse that stretches beyond the known planets. Deep within the heart of this icy ring lies a massive group of objects that astronomers refer to as classical inhabitants, moving through paths that seem completely untouched by outside worlds. The very first of these independent bodies was detected in the early 90s, breaking a long silence and proving that the space beyond Pluto was teeming with ancient matter. These classical objects follow remarkably circular paths that rest gracefully in the main plane of the solar system, never venturing too close to the gravitational grasp of Neptune. Because their orbits have remained peaceful and stable for billions of years, they represent the most pristine, undisturbed material from the original solar nebula. They float in a state of eternal tranquility, completely detached from the chaotic migrations that reshaped the inner solar system during its turbulent youth. A particularly fascinating family of icy worlds shares a profound mathematical bond with Neptune, locked in a permanent gravitational embrace known as an orbital resonance. For every 3 times the giant blue planet completes its journey around the Sun, these resonant objects complete exactly 2 loops of their own. This precise choreography prevents them from ever colliding with the giant planet, even though their paths frequently cross its orbital track. This beautiful cosmic rhythm acts as a protective shield, keeping these objects stable within a dynamic and ever-shifting environment. How extraordinary it is to think that across billions of miles of empty space, the invisible strings of gravity create such flawless, synchronized movements among thousands of frozen fragments. Beyond the structured lanes of the main belt lies a much more chaotic and wild population of frozen bodies that inhabit the outer fringes of the system. These objects belong to a region known as the scattered disk, a place where paths are highly elongated and tilted at extreme angles to the rest of the planets. Long ago, these unfortunate wanderers ventured too close to Neptune and were violently thrown outward by the immense gravity of the ice giant. Their journeys now take them thousands of times farther from the Sun than the Earth, sending them into the deep, lonely spaces that border the interstellar void. They exist as cosmic exiles, moving along lonely, sweeping trajectories that bridge the gap between our planetary neighborhood and the infinitely distant stars. Our understanding of this distant wilderness transitioned from blurry pixels to breathtaking reality when a robotic explorer from Earth made a historic voyage through the outer dark. Traveling faster than any spacecraft before it, this small mechanical scout traversed billions of miles over nearly a decade to capture our very first close-up images of these remote worlds. The data returned to Earth revealed a landscape of astonishing complexity, featuring towering mountains of solid water ice, vast plains of frozen nitrogen, and active geological processes that defied all scientific expectations. This mission proved that even in the deepest freeze of the solar system, nature retains the power to create diverse and breathtakingly beautiful landscapes. The Silent spacecraft continues its journey today, drifting deeper into the dark belt as a quiet ambassador of human curiosity. During this historic journey through the outer dark, the spacecraft encountered a tiny, primitive object that offered a perfect glimpse into how worlds are born. This ancient body resembles a cosmic snowman, formed by two distinct icy spheres that gently touched and fused together during the very earliest days of the solar nebula. Unlike the violent, destructive collisions that often occur in the inner solar system, this gentle merger occurred at a remarkably slow and peaceful pace. The resulting structure has remained completely unblemished and unaltered for over 4 billion years, serving as a pristine example of the initial stages of planetary growth. Looking at this strange, dual-lobed object is like looking at a frozen snapshot of time, a physical manifestation of the quiet, constructive forces of the early universe. When we examine the surfaces of these distant icy bodies, we find a surprisingly rich palette of colors that tells a story of complex chemical evolution under the starlight. While some objects appear as a neutral, slate gray, others exhibit deep, rust-red hues that are among the most intense colorations in the entire solar system. These vivid red tones are caused by the presence of complex organic molecules known as tholins, which form when simple ices are bombarded by cosmic rays and ultraviolet light over eons of time. These dark, rich chemical carpets absorb what little sunlight reaches them, creating a subtle, warm glow against the cold blackness of space. This delicate coloring reminds us that even in an environment of absolute freeze and near total darkness, light and chemistry dance together to create complex patterns of matter. As telescopes peer deeper into the quiet depths of the belt, they reveal that many of these frozen wanderers do not travel through the void alone. A significant number of these objects exist as binary systems, where two bodies of similar size are locked in a permanent orbital dance around a shared center of mass. These pairs move through the dark like slow-motion dancers, their gravitational bond keeping them united across vast stretches of empty space. The existence of so many twin systems suggests that their formation was a gentle and orderly process, occurring within a dense but peaceful cloud of primordial dust. Watching these pairs drift through the centuries inspires a feeling of deep companionship, a reminder that even in the most isolated corners of the cosmos, objects find harmony with one another. One of the most profound mysteries of this outer region is the existence of a sudden and dramatic boundary that astronomers refer to as the cosmic cliff. As we travel outward past a distance of about 50 times the Earth's orbit, the density of icy objects suddenly drops to almost zero, as if a great line had been drawn in the dark. Scientists have searched extensively for a reason behind this abrupt end to the belt, wondering if a hidden planet or some ancient cosmic event cleared the outer spaces of material. This sharp drop-off leaves us with a sense of wonder, a quiet question mark at the very edge of our immediate stellar neighborhood. Beyond this cliff, the solar system seems to plunge into an even deeper, more profound silence, preparing us for the vast emptiness of interstellar space. Among the larger worlds that dwell in this freezing domain, there is a truly unique dwarf planet that challenges our understanding of celestial shapes and motions. This remarkable body spins so rapidly that its entire structure has been stretched into an elongated, egg-like shape, resembling a polished white stone. Despite the extreme cold, its surface is covered in a layer of brilliant, crystalline water ice that reflects the distant starlight with exceptional clarity. This spinning world is accompanied by its own system of small moons, and even a faint, delicate ring of icy debris, all created during an ancient, colossal impact long ago. Contemplating this rapidly spinning, elongated jewel reminds us of the endless variety of form and motion that exists within the quiet sanctuary of the outer solar system. Deep within this frozen expanse drifts another massive sphere of ice and rock, a distant world that glows with a brilliant white intensity against the dark. Discovered shortly after the turn of the 21st century, this serene dwarf planet is covered in a remarkably pure blanket of frozen methane and ethane ices. Unlike worlds closer to the sun, it possesses no substantial atmosphere, leaving its frozen, ultra-cold plains directly exposed to the quiet vacuum of space. The extreme cold keeps these volatile chemicals trapped in a solid state, creating a smooth and highly reflective surface that shines like a distant diamond. As it completes its long, 300-year journey around the sun, this silent sentinel reminds us of the endless variety of frozen landscapes waiting to be mapped in the deep outer dark. Farther still, on the very edges of the known system, we encounter a massive and exceptionally bright world whose discovery ignited a grand debate about the very definition of a planet. This heavy, icy sphere is so distant that its orbit takes it far beyond the main boundaries of the belt, traversing a highly tilted path that requires over 500 Earth years to complete. Its surface is a dazzling expanse of nitrogen and methane ice, reflecting almost all the faint light that manages to reach its remote coordinates. The sheer size and mass of this distant body forced astronomers to reconsider how they classify the citizens of the outer solar system, ultimately giving birth to the category of dwarf planets. It stands as a powerful testament to the hidden complexity of our cosmic neighborhood, a reminder that the outer dark still holds secrets large enough to reshape our understanding of the universe. Within the peaceful lanes of the classical belt, scientists have observed a fascinating divide between two distinct populations of icy bodies that look and move differently from one another. One group, known as the cold classicals, follows nearly perfect circular paths that lie completely flat within the main plane of our solar system. These objects have remained entirely undisturbed since their birth, preserving the original conditions of the primordial solar nebula in their purest form. In contrast, the hot classicals move along highly tilted and elongated paths, suggesting they were born closer to the sun and violently pushed outward during a period of ancient planetary migration. This hidden structural duality reveals that the seemingly uniform wasteland is actually a complex tapestry woven from different historical eras of our cosmic history. Floating gracefully through the dark is another substantial world that has recently astonished researchers with its unexpected and mysterious structural features. This dark, icy body is accompanied by a delicate, faint ring of debris that orbits at a distance far greater than traditional physics would seem to allow. According to long-standing scientific principles, material at this extreme distance should have naturally coalesced into a small moon over time, rather than remaining scattered as a ring. The existence of this rule-breaking ring suggests that the intense cold and unique gravitational environment of the outer belt alter the normal rules of cosmic architecture. Watching this lone world and its impossible ring drift through the silent void inspires a deep appreciation for the endless surprises that nature hides within the shadows. Tracing an orbital path that mirrors the most famous dwarf planet in a beautiful mathematical inversion, we find a shadowy world often called the anti-Pluto. While it shares the exact same orbital period and resonance with Neptune, it remains permanently positioned directly opposite its famous counterpart, as if the two worlds were engaged in an eternal game of cosmic hide-and-seek. This dark, icy object is covered primarily in water ice and is accompanied by a relatively large, faithful moon that circles it closely. Together, this planetary pair moves through the deep freeze with a quiet elegance, their synchronized movements perfectly balanced by the invisible hand of gravity. Their relationship highlights the deep geometric harmony that underpins the outer solar system, turning a lonely journey into a perfectly choreographed celestial dance. The true magic of this frozen reservoir becomes apparent when we contemplate how these dark, icy bodies can transform into the brilliant comets that occasionally illuminate our night skies. Deep within the belt, the intense cold keeps gases like carbon monoxide and methane locked away as solid, unyielding ice for billions of years. However, if a gentle gravitational disturbance pushes one of these objects inward toward the sun, the sudden increase in warmth triggers a dramatic physical awakening. The ancient ice begins to bypass the liquid phase entirely, turning directly into gas and lifting clouds of dust to form a magnificent, glowing envelope around the waking nucleus. This process of sublimation bridges the gap between the dark, invisible wasteland and the vivid, artistic displays of light that have inspired wonder throughout human history. As these displaced icy wanderers make their way into the inner solar system, they often transition through a chaotic, intermediate zone occupied by a family of objects known as centaurs. These unstable bodies cross the orbits of the giant gas planets, caught in a turbulent gravitational tug-of-war between Jupiter, Saturn, Uranus, and Neptune. Because their paths are constantly altered by these massive worlds, their lifetimes in this region are brief, lasting only a few million years before they are either thrown into the sun or cast out of the system entirely. They represent a dynamic bridge between the quiet permanence of the outer belt and the active, changing environment of the inner planets. Observing these intermediate travelers allows us to witness the ongoing, living evolution of our solar system as it continuously recycles its ancient materials. Although the modern outer belt is an incredibly sparse and quiet place where objects rarely meet, its history is marked by ancient, slow-motion collisions that left behind massive fields of microscopic dust. Millions of years ago, when the region was far more crowded, gentle impacts between icy bodies shattered their surfaces and released clouds of tiny volatile crystals into the void. This ancient dust remains scattered throughout the region, forming a faint, invisible ring that absorbs and scatters the faint sunlight passing through the outer system. Spacecraft traveling through this zone can detect these tiny primordial particles, using them as clues to reconstruct the ancient history of impacts that shaped the outer worlds. This delicate shroud of cosmic dust reminds us that even the smallest fragments carry the memories of grand, historical events from the dawn of creation. The preservation of these icy worlds is not entirely perfect, as their surfaces are constantly shaped by a slow and invisible process known as space weathering. Over the course of eons, the outer solar system is continuously bombarded by high-energy cosmic rays from distant galaxies and ultraviolet radiation from our own sun. This relentless, gentle bombardment breaks apart the simple chemical bonds of the surface methane and ammonia ices, triggering a slow transformation into complex, dark organic networks. This energetic alchemy is what darkens the surfaces of the objects over time, coating them in a protective, reddish mantle that insulates the pristine ice hidden beneath. It is a beautiful paradox that the most destructive radiations in the cosmos act as an artistic brush, painting the outer worlds with the deep colors of time. When we look beyond our own stellar neighborhood into the vast reaches of the galaxy, we discover that our frozen outer ring is not a unique feature, but a common characteristic of planetary systems. Astronomers using powerful space telescopes have detected massive rings of cold, icy dust encircling bright, young stars across the galaxy. These distant structures are cosmic twins to our own outer belt, representing the raw leftovers of planetary formation occurring around other suns across the universe. By studying the quiet dynamics of our own frozen wilderness, we gain a deeper understanding of how planetary systems grow, mature, and evolve throughout the wider cosmos. This realization connects our lonely outer frontier to the grand, universal patterns of creation, making the deep dark feel less like an empty void and more like a shared cosmic home. To understand the origin of the luminous travelers that grace our night skies, we must draw a clear distinction between the different realms of ice that border our system. While the unimaginably distant and spherical Oort cloud sends us long-period comets that may take millions of years to return, it is this flatter, closer ring past Neptune that serves as the exclusive nursery for short-period comets. These predictable visitors complete their orbital journeys in less than 200 Earth years, returning to the inner solar system with a rhythmic familiarity that allows generations of humans to witness their displays. Their orbits remain closely aligned with the main plane of the planets, reflecting the flattened, disc-like shape of the reservoir from which they were originally cast out. By studying these short-period wanderers, we are directly examining the displaced architecture of the outer ring itself, catching glimpses of its deep freeze from the comfort of our warm world. When these frozen messengers are nudged from their ancient homes beyond Neptune, they frequently fall under the immense gravitational influence of Jupiter, the largest of the gas giants. This massive planet acts as a celestial gatekeeper, catching the incoming ice worlds and permanently altering their trajectories into much smaller, tighter loops. This specific group of travelers becomes known as the Jupiter family comets, possessing brief orbital paths that require less than 20 years to complete a single journey around the Sun. Under Jupiter's relentless control, their orbits become compressed, forcing them to visit the warm inner solar system far more frequently than their distant relatives. This frequent exposure to solar heat causes them to age rapidly, shedding their volatile materials in beautiful, desperate outbursts of gas and dust until they are completely exhausted. Deep within the classical lanes of this frozen wasteland, another massive resident named Varuna quietly turns through the dark, offering clues about the physical limits of cosmic material. This large, icy world rotates on its axis at an incredible speed, completing a full turn in just over 6 hours, a rate that pushes its structural integrity to the absolute limit. Because it is composed of a delicate mixture of soft ice and porous rock, this rapid spinning has flattened its shape into an elongated ellipsoid, much like a smooth, stretched stone found on a dark beach. The intense centrifugal forces prevent the object from pulling itself into a perfect sphere, demonstrating how rapid motion can override the natural rounding power of gravity. Observing this spinning, elongated shape reminds us that even in the frozen quiet, dynamic physical forces continue to reshape the contours of the outer worlds. Floating in a synchronized 2 to 3 orbital resonance with the blue ice giant, the dark world known as Ixion traces its ancestral path through the distant cold. Discovered during the early years of the 21st century, this large Plutino stands out due to its remarkably dark and deeply colored surface coat. Spectroscopic analysis reveals a landscape dominated by a thick mixture of dark carbon compounds and complex organic networks formed by eons of solar radiation. This organic mantle absorbs nearly all the faint starlight that reaches it, making the world appear as a faint, reddish shadow moving silently against the black backdrop of the galaxy. The preservation of these complex materials on its surface suggests that Ixion has avoided major disruptive impacts for billions of years, remaining a pristine vault of primordial chemistry. The modern scarcity of mass within this cold outer ring is beautifully explained by a sweeping historical theory known to scientists as the nice model of planetary migration. This grand narrative suggests that billions of years ago, the giant gas planets were packed much closer together and surrounded by a massive, dense disk of trillions of icy bodies. As Jupiter and Saturn slowly drifted into a precise gravitational alignment, their combined pull sent shockwaves through the outer solar system, destabilizing the orbits of Uranus and Neptune. The blue ice giant, Neptune, was pushed violently outward into the dense primordial disk, acting like a cosmic bowling ball that scattered the fragile ice worlds in every direction. This ancient gravitational storm hurled the vast majority of the icy bodies out into interstellar space, leaving behind only the sparse, quiet remnant population that we observe today. When we consider the physical interior of the smaller, unstudied fragments within this icy wilderness, we find structures that resemble delicate, frozen sponges rather than solid rock. Because these objects formed through the gentle accumulation of microscopic ice crystals and dust grains in a low-gravity environment, they were never subjected to the intense heat and pressure that compress the inner planets. Their interiors are highly porous, filled with vast networks of microscopic voids and empty chambers that can make up more than half of their total volume. This airy, fragile construction means that these bodies are incredibly lightweight, possessing a density so low that many of them would float effortlessly if placed in a massive ocean of water. This structural delicacy explains why comets can fragment so easily when exposed to the thermal stresses of the inner solar system, revealing their fragile, ghostly nature. The visual diversity of the objects drifting in this distant realm is highlighted by their astonishing variations in albedo, the scientific measure of how much light a surface reflects. Some of the most ancient, undisturbed bodies are as dark as fresh charcoal, reflecting less than 4% of the faint sunlight that strikes their weathered crusts. This extreme darkness is the result of billions of years of cosmic ray exposure, which systematically strips away volatile ices and leaves behind a charred residue of complex carbon compounds. Conversely, other worlds within the same region are as brilliantly white as fresh snow, reflecting nearly 90% of all incoming light due to active processes that continuously coat them in clean nitrogen or methane frost. This striking contrast creates a silent landscape of light and shadow, where charcoal dark remnants and glowing white jewels share the same frozen lanes of space. One of the most scientifically valuable characteristics of these deep freeze worlds is their ability to trap and preserve ancient noble gases within their icy lattices. Elements like argon, krypton, and xenon do not easily combine with other chemicals, meaning they can only be captured if the environment remains at temperatures close to absolute zero during their formation. Because the outer belt has maintained this extreme chill for over 4 billion years, these gases remain securely locked inside the frozen water and methane structures of the drifting fragments. When a short period comet leaves this reservoir and melts near the sun, it releases these trapped vapors, allowing space probes to measure their exact chemical ratios. These measurements provide an immutable fingerprint of the temperature and density of the original solar nebula, serving as a chemical time capsule from the very birth of our star. The mechanism that initiates the long, winding journey of a short-period comet toward the inner solar system often begins with a remarkably gentle interaction within the belt itself. Although the distances between individual objects are immense, the sheer number of fragments guarantees that subtle gravitational brushes and slow-speed collisions occur over millions of years. These gentle encounters do not shatter the bodies, but instead alter their orbital speeds by just a few meters per second, a tiny adjustment that is magnified over vast distances. This minor shift slowly unravels the object's stable circular path, causing it to fall inward toward the sun under the distant pull of solar gravity. It is a process marked by extraordinary patience, where a soft nudge in the frozen quiet of the outer dark sets the stage for a spectacular display of light millions of years later. This continuous leakage of icy bodies from the outer ring toward the warmth of the sun reveals that the Kuiper Belt is slowly, but surely depleting its ancient population over cosmic timescales. Every time a short-period comet enters the inner system, it enters a destructive cycle of heating and sublimation that it cannot ultimately survive, leading to its eventual disintegration or ejection into deep space. This means that the frozen wilderness we observe today is dynamic, serving as a slowly draining reservoir that has been losing its citizens for billions of years. Eventually, in the unimaginably distant future of our solar system, the remaining material will become even scarcer, leaving behind an even deeper and more absolute silence. To contemplate this region is to witness a grand, slow-motion evaporation, a beautiful and temporary gathering of ancient ice worlds that are slowly dissolving into the larger history of the universe. Because many of the frozen fragments in this distant ring are far too small and dark to be seen directly by even our greatest telescopes, astronomers must employ a brilliant method of indirect observation known as stellar occultation. They watch a distant, bright star in the deep galaxy and wait with absolute patience for a tiny, invisible ice world to pass precisely in front of it. For a mere fraction of a second, the starlight blinks out or dims, casting a fleeting, microscopic shadow across the telescopes on Earth. By measuring the exact duration and shape of this brief darkness, scientists can calculate the size and path of an object that remains otherwise completely invisible to human eyes. This elegant cosmic shadow puppetry allows us to map the hidden population of the outer dark, proving that even the smallest fragments can briefly announce their presence against the tapestry of the stars. When scientists analyze the specific structure of the water ice coating the larger worlds of this outer domain, they encounter a profound geological puzzle that hints at hidden internal warmth. In the absolute freeze of the outer system, water ice should naturally exist in an amorphous, disordered state, where molecules are locked together in a chaotic arrangement. Yet, spectroscopic data from several massive objects reveals the presence of crystalline ice, a highly ordered structure that can only form when temperatures rise above a certain threshold. This discovery suggests that these seemingly dead worlds once possessed internal heat sources, perhaps driven by the decay of radioactive elements deep within their rocky cores. The presence of these crystals means that beneath the frozen, motionless surfaces, a slow and ancient thermodynamic heart once beat, gently altering the face of the ice over millions of years. The ancient journeys of short-period comets from this outer reservoir may have played a fundamental role in nurturing the conditions necessary for life on our own world. Billions of years ago, during a period of intense cosmic bombardment, thousands of these ice-rich fragments were diverted from their quiet orbits and sent crashing into the young, barren Earth. As they dissolved in the heat of our planet's early atmosphere, they deposited vast quantities of pure water ice and complex organic compounds that had been preserved in the deep freeze since the dawn of time. Many scientists believe that a significant portion of the water filling our modern oceans and the carbon building blocks within our cells were carried across space by these frozen wanderers. This connects our everyday lives directly to the frozen wasteland beyond Neptune, suggesting that the gentle oceans of Earth are filled with the melted remnants of the outer dark. This vast frozen ring exists in a unique interstellar borderland where the protective bubble of our sun begins to lose its dominance against the grand theater of the galaxy. The solar wind, a constant stream of energetic particles blowing outward from our star, travels billions of miles through space until it reaches this outer territory, where it begins to slow down and collide with the cold gas of interstellar space. This boundary zone subjects the icy objects to a complex and shifting environment, where they are continuously bathed in a mixture of fading solar particles and intense cosmic rays from distant exploding stars. The frozen bodies act as passive recorders of this celestial conflict, their surfaces absorbing the scars of both our sun's final breaths and the raw energy of the wider galaxy. Floating in this cosmic shoreline, they represent the absolute transition between our immediate solar neighborhood and the infinite star systems beyond. Among the unique citizens of the classical belt, the large world known as Salacia offers a fascinating look at how density and light absorption vary in the outer dark. This substantial object reflects an incredibly small amount of sunlight, possessing a charcoal-like surface that absorbs almost all the faint illumination reaching its distant position. Despite its dark and weathered exterior, planetary scientists have calculated that Salacia possesses a surprisingly high density compared to its icy neighbors, indicating a substantial core of solid rock hidden beneath its dark mantle. It is accompanied by a small, faithful moon named Actea, which circles its dark master in a perfectly circular and tranquil orbit every few Earth days. Together, this heavy, dark pair drifts through the centuries, a striking example of the heavy, rocky foundations that can lie hidden beneath the most frozen and unreflective crusts of the outer system. On the outermost fringes of the scattered disk, astronomers have tracked a select group of highly detached objects whose bizarre, elongated paths point to a profound cosmic secret. These extreme wanderers travel along paths that are heavily tilted and stretched out into the deep dark, never venturing close enough to Neptune to be influenced by its blue gravity. Remarkably, the orbits of these distant bodies are all clustered together in the same specific direction of space, a mathematical coincidence that is highly unlikely to happen by pure chance. This strange alignment has led modern astrophysicists to hypothesize that an undiscovered, massive planet, many times heavier than Earth, may be lurking in the absolute darkness far beyond the belt. This ghostly world would act as a distant gravitational shepherd, gently pulling the paths of the smaller ice worlds into their synchronized arrangement, and reminding us that the deepest dark may still hold a major planetary king. Our modern map of this frozen wilderness is on the verge of a magnificent expansion, driven by a new generation of monumental ground-based survey telescopes designed to sweep the night sky. sitting atop high, dark mountains. These advanced observatories utilize giant cameras to capture sweeping, highly detailed images of the cosmos night after night. By comparing these digital snapshots over weeks and months, powerful computers can detect the incredibly slow, ghostly drift of thousands of previously unknown outer worlds against the fixed background of the stars. This relentless astronomical watch will soon reveal smaller, fainter fragments that have remained completely hidden from human awareness since the beginning of civilization. This grand technological awakening promises to transform our understanding of the belt from a collection of isolated points into a fully realized, living portrait of a vast and interconnected cosmic ecosystem, floating gracefully within the resonant lanes of the outer dark. The mid-sized world named Varda carries out its long journey in the company of a delicate and tightly bound companion. Named after ancient mythological entities of light and creation, this icy body behaves as a classic binary system, its physical characteristics closely tied to its partner moon, Ilmara. The two bodies circle one another in a beautifully balanced gravitational loop, their mutual pull allowing scientists to precisely calculate their combined mass and structural density. The surface of Varda is coated in a mixture of dark water ice and complex organic tholins, giving it a soft, reddish glow under the faint light of the distant sun. Their relationship illustrates that even the moderately sized citizens of the outer belt are fully realized worlds, possessing their own systems of orbital mechanics that operate with absolute precision in the quiet void. When a short-period comet is repeatedly pulled into the warm inner solar system, its physical journey eventually enters a quiet, final chapter known as extinction. With every close pass around the sun, the intense solar heat boils away the volatile layers of nitrogen, methane, and water ice, releasing them into space as glowing tails. Over hundreds of orbits, the comet sheds its entire icy mantle, leaving behind only a dark, inactive core composed of tightly packed dust, heavy metals, and porous rock. This exhausted remnant no longer produces a brilliant coma or a spectacular tail, becoming completely indistinguishable from a dark, primitive asteroid drifting silently through the inner system. These extinct comets remind us that the bright displays of light we admire in our night skis are temporary phenomena, representing a brief, energetic awakening before the object returns to a state of permanent, rocky slumber. The continuous, slow-motion collisions that occur within the frozen outer belt do not only produce spectacular comets, but also fill the entire solar system with an invisible rain of microscopic space dust. As these tiny icy particles are ground down by collisions and pushed inward by the subtle pressure of sunlight, they slowly migrate across billions of miles toward the inner planets. Every single day, tons of this primitive, outer system dust gently filter down through the atmosphere of the Earth, drifting silently through our skis before settling on the ground. These microscopic particles carry the pure, unblemished chemical composition of the ancient outer ring, bringing a literal piece of the distant wilderness directly to our doorsteps. To look at the quiet dust settling in the air around us is to realize that the most remote and frozen frontier of our solar system is constantly raining down upon us, connecting the deep dark to our immediate world. Deep within the classical ring floats the massive, dark world known as Quawar, accompanied by its tiny, faithful moon named Waywat. This small moon travels in an eccentric path around its parent, providing astronomers with the vital gravitational clues needed to weigh this distant titan. The composition of this duo consists of a surprisingly heavy mixture of rock and dense water ice, suggesting that they formed in a more crowded region of the early nebula before drifting to their current home. Waywat is believed to be a remnant of an ancient, gentle collision, a fragment blasted off the main body that refused to leave its side. Together, they navigate the deep freeze of the outer system, their slow-motion orbital dance serving as a beautiful testament to the enduring bonds of gravity in the furthest corners of space. As we contemplate the outermost boundaries of this icy wilderness, we must look beyond our sun to understand the subtle forces that shape the paths of the most distant wanderers. The grand gravitational pull of the entire Milky Way galaxy, known to astronomers as the galactic tide, exerts a slow and continuous influence on the objects resting at the very edge of our system. Over millions of years, this gentle galactic pull can slightly warp the orbits of the outermost scattered disk objects, lifting their closest points of approach far away from the disturbing influence of Neptune. This cosmic interaction transforms these lonely ice worlds into completely detached citizens, effectively cutting their physical ties to the major planets. It is a profound realization that the architecture of our outer solar system is shaped not only by our local star, but also by the collective mass of billions of distant suns rotating in the night. The quiet family of cold classical objects exhibits an astonishing uniformity of color that sets them completely apart from their more chaotic neighbors. Every single one of these peaceful, unperturbed bodies is covered in an ultra-red coat of ancient organic material, with absolutely no blue or neutral-colored members among them. This perfect color consistency provides definitive proof that this specific family formed exactly where we see them today, never leaving their original freezing birthplace since the dawn of creation. The hot classicals, by contrast, display a chaotic mixture of blues, grays, and reds, betraying their diverse origins in warmer regions closer to the young sun. This stark color division allows us to read the history of the solar system like layers of ancient rock, where a simple shade of crimson reveals a story of 4 billion years of absolute stillness. Among the many binary pairs drifting through the dark, scientists have discovered a unique group known as wide binaries, where two components are separated by immense distances, yet remain delicately linked. These fragile pairs are separated by tens of thousands of miles of empty space, their gravitational embrace so weak that the slightest cosmic breeze could tear them apart. The survival of these delicate systems over billions of years proves that the outer belt has remained an incredibly peaceful and gentle environment, completely free from violent disruptions or close planetary encounters. Astrophysicists believe these twins did not form through violent impacts, but rather grew together simultaneously from a single, slowly swirling cloud of primordial dust. Watching these wide, fragile pairs drift through the centuries inspires a deep sense of wonder at how something so delicate can endure for eons in the vast darkness. When our robotic explorer sent back the first close-up images of a primitive, dual-lobed object in the deep belt, scientists noticed a startling geological feature that rewrote our understanding of cosmic debris. The ancient, unblemished surface of this frozen snowman showed a remarkable lack of small impact craters, suggesting that the region has experienced far fewer collisions with tiny fragments than anyone had predicted. This scarcity of small craters implies that the outer solar system does not contain a continuous distribution of microscopic pebbles and rocks, but is instead dominated by larger, fully formed objects. It suggests that during the dawn of creation, primordial dust bypassed the slow stage of accumulating tiny rocks and instead collapsed directly into larger bodies through gravitational instabilities. This single observation dissolved decades of scientific assumptions, revealing that the building blocks of planets may have formed much faster and more cleanly than we ever imagined. The precise orbital arrangements of the icy bodies provide a flawless mathematical record of how the giant blue planet, Neptune, executed its ancient outward journey. If the ice giant had moved outward in a chaotic, jerky fashion, its powerful gravity would have completely obliterated the delicate families of objects locked in resonance. Instead, the survival of these highly structured orbital lanes proves that Neptune migrated in a remarkably smooth, continuous glide over tens of millions of years. This slow, majestic march allowed the planet's gravitational resonances to act like a gentle broom, sweeping the icy fragments forward and trapping them in stable paths without destroying their delicate configurations. The outer belt stands as a monument to this smooth planetary migration, a silent architectural blueprint that allows us to reconstruct the slow and graceful movements of giant worlds from the distant past. The largest and brightest worlds of this freezing domain possess a remarkable ability to generate temporary, fleeting atmospheres when their long journeys bring them closest to the distant sun. During these rare periods of perihelion, the slight increase in solar warmth is just enough to cause a tiny fraction of the surface methane and nitrogen ice to turn into gas. This vapor rises gently above the frozen plains, creating a thin, ethereal shroud of atmosphere that envelops the world for a few brief decades. As the planet inevitably drifts back out into the deep freeze of its long orbital cycle, the temperature drops once more, and the fragile atmosphere completely collapses, freezing back onto the surface as a pristine layer of fresh frost. This slow, centuries-long respiration represents a delicate seasonal cycle, a silent breath of gas that appears and disappears in absolute harmony with the orbital rhythm of the cosmos. When we examine the overall orientation of this massive frozen ring, we discover that its average orbital plane aligns perfectly with the true gravitational center of our solar system. This fundamental orientation, known to astronomers as the invariant plane, is determined by the total angular momentum of all the planets combined, dominated heavily by the massive bulk of Jupiter. While individual inner planets tilt slightly away from this true center due to local interactions, the vast, scattered collective of the outer belt remains perfectly anchored to this mathematical baseline. It is as if the thousands of drifting ice worlds serve as a cosmic compass, pointing directly to the original rotational alignment of the primordial nebula that birthed our star. Contemplating this deep geometric alignment reveals the hidden thread of order that binds the most distant, lonely fragments to the grand mechanical core of our planetary family. The entire region can be beautifully understood as a magnificent, fossilized graveyard of planetary dynamics, where the orbits themselves are the ancient bones waiting to be studied. Unlike the inner solar system, where the constant movement of rocky planets and intense solar radiation have erased the clues of the past, this cold sanctuary preserves every gravitational scar, every eccentric tilt, every resonant lock, and every scattered path represents a physical record of an event that occurred billions of years ago. By reading these orbital signatures, astrophysicists can trace the ancient positions of the giant planets, the strength of the early solar winds, and the chaotic dances of long-lost worlds. The belt does not merely hold ancient matter. It holds ancient motion, frozen in time and protected by the absolute quiet of the deep outer dark. Before an icy wanderer from this reservoir can fully transition into a short-period comet, its path often takes it through a temporary holding zone associated with the giant planets. Some of these displaced fragments become briefly trapped within the stable gravitational clouds that travel ahead of and behind Neptune or Jupiter, acting as temporary Trojan companions. They spend thousands of years drifting within these secure pockets of space, sharing the orbit of a giant world before another subtle gravitational perturbation jars them loose once more. This intermediate pause represents a quiet, transitional chapter in their long journeys, a moment of rest before they are hurled into the volatile environment of the inner system. Watching these fragments transition from the deep belt through these planetary waystations highlights the continuous, interconnected pathways that weave through the seemingly empty spaces of our cosmos. The pristine fragments of this outer dark hide a profound paradox that forces us to rethink the chaotic birth of our stellar system. When scientists analyzed the microscopic dust grains returned from short-period comets, they discovered crystals of olivine and pyroxene, minerals that can only forge in the intense heat close to a young star. The presence of these high-temperature rocks inside frozen bodies that spent billions of years past Neptune implies a massive, ancient mixing process. It tells a story of a primordial nebula that acted like a giant convective furnace, violently throwing hot materials from the inner zone out into the freezing cosmic suburbs before the planets were fully assembled. This means that every dark ice world is a mosaic of extremes, holding within its frozen chest the literal ashes of the inner solar system's fiery birth. Floating along a highly stretched and lonely path on the edge of the system is the massive dwarf planet known as Gong Gong, wrapped in a mantle of deep crimson. This distant world is large enough to retain a faint, transient layer of methane gas on its surface, despite the relentless stripping action of cosmic radiation over the eons. It is accompanied by a tiny, faithful moon named Xiangliu, which orbits its heavy master in a slow and silent circle against the background stars. The crimson hue of Gong Gong is among the most dramatic in the outer system, indicating a surface rich in complex organic molecules that have been baked by starlight for over 4 billion years. Watching this large, red world slide silently through the extreme cold reveals the astonishing diversity of the larger citizens that govern the outer borders of our stellar home. The abrupt ending of this frozen ring, known to us as the cosmic cliff, may find its explanation in the crowded environment where our sun was originally born. Long before the planets settled into their current peaceful configurations, our young star resided inside a dense cosmic nursery surrounded by hundreds of stellar siblings. During this ancient epoch, a massive neighboring star may have made a close flyby, its immense gravity slicing through the outer edges of our sun's primordial protoplanetary disk. This stellar encounter would have violently stripped away the outer layers of ice and dust, truncating the reservoir and leaving behind the sharp boundary we observe today past 50 times the Earth's orbit. To look at the outer edge of the belt is to feel the ghostly touch of a long-lost sister star, an ancient cosmic brush that shaped the definitive borders of our modern solar system. As astronomers categorize the thousands of icy wanderers, they notice an intriguing relationship between the physical size of an object and the chaotic nature of its orbital path. The cold classical population, which occupies perfectly peaceful and flat circular paths, is composed almost entirely of smaller, modestly sized ice fragments and binary pairs. In contrast, the massive dwarf planets and heavy planetary bodies are almost exclusively found within the dynamically hot and scattered families, tracing highly tilted and eccentric tracks. This striking division suggests that the early gravitational storms selectively spared the smaller, delicate structures in the midplane while aggressively flinging the larger, more massive bodies into wild trajectories. It reveals a beautiful cosmic irony where the smallest, most fragile pieces of ice were granted absolute peace, while the heavy giants were condemned to an eternity of restless, looping journeys. Though the modern belt appears as a motionless and frozen wasteland, it is continuously shaped by an invisible, slow-motion process known as collisional grinding. Over millions of years, the sparse paths of these icy bodies inevitably intersect, causing gentle impacts that systematically break down larger rocks into smaller fragments. This relentless cosmic mortar and pestle gradually transforms solid planetesimals into pebbles, and pebbles into a fine, microscopic dust that drifts between the worlds. This ongoing destruction is what continuously replenishes the faint, glowing ring of infrared dust that wraps around the outer solar system, preventing it from completely vanishing over time. It is a process of infinite patience, where the solid history of ancient worlds is slowly and beautifully ground down into a soft cosmic mist that fills the silent void. Because the smaller fragments within this icy wilderness lack the gravitational strength to hold onto a protective atmospheric shield, their bare surfaces are completely exposed to the raw environment of open space. High-energy ions from the solar wind and cosmic rays from distant supernova explosions strike the exposed ice directly, penetrating deep into the molecular structures of the surface layers. This relentless atomic bombardment slowly breaks apart the clean crystalline structure of the water ice, transforming it into a disordered, amorphous state through a process called lattice damage. Over billions of years, this invisible radiation darkens and alters the physical texture of the crust, turning smooth ice into a highly porous, chemically altered mantle that insulates the interior. This cosmic shielding protects the inner secrets of the fragment, ensuring that the deeper ice remains completely untouched by the energetic chaos of the galaxy. When a displaced ice world finally completes its long journey from the outer ring and enters the inner solar system as a short-period comet, it faces a perilous environmental transition. The immense gravitational tides of the Sun and the massive gas giants exert powerful, tearing forces on the comet's lightweight and highly porous structure. If the frozen traveler ventures too close to a planetary giant, these invisible gravitational forces can easily overcome the weak structural bonds of the spongy ice, shattering the single body into a long train of individual fragments. This spectacular tidal disruption transforms a solitary wanderer into a string of glowing cosmic pearls, each piece doomed to burn up or collide with other worlds. This dramatic destruction highlights the ultimate vulnerability of these outer system relics, showing that the structures born in the absolute peace of the deep freeze are ill-equipped to survive the violent physics of the inner worlds. Traced along an unimaginably long and lonely trajectory, the mysterious world known as Sedna serves as a profound bridge between the outer belt and the infinite depths of the inner Uit cloud. This exceptionally distant, reddish body moves on a highly elongated path that requires 11,000 Earth years to complete just one single journey around our central star. At its furthest point, Sedna travels nearly 1,000 times further from the Sun than the Earth, venturing into an absolute darkness where our Sun appears as nothing more than a piercing, cold pinprick of light. Because its path never brings it close enough to feel the gravitational disturbance of Neptune, its unique orientation cannot be explained by traditional planetary interactions. It stands as a silent sentinel of the absolute deep, a frozen world that may have been pulled into its sweeping orbit by a passing star from our Sun's ancient birth cluster. By carefully cataloging the dimensions of these frozen citizens, planetary scientists have mapped a fascinating mathematical feature known as the size distribution knee. When counting objects from the largest dwarf planets down to mid-sized rocks, the population increases at a steady, mathematically predictable rate that reflects an orderly process of growth. However, once the measurements drop below a specific diameter of a few miles, the expected number of smaller fragments suddenly and dramatically decreases. This unexpected mathematical bend reveals the exact boundary where the forces of planetary creation transitioned into the forces of destructive collisions over cosmic time. It tells us that the smaller fragments are being systematically ground away into microscopic dust faster than they can be replenished, leaving behind a clear signature of the ancient, slow-motion warfare that shapes the outer dark. The profound preservation found within this deep freeze extends beyond simple water ice to encompass the complex, prebiotic organic molecules that form the foundations of biology. Freezing temperatures hovering just above absolute zero act as an immutable cosmic vault, preventing these delicate carbon chains from breaking down or reorganizing into simpler structures. Amino acids, complex polymers, and rich hydrocarbon networks remain perfectly suspended within the icy matrices of these drifting fragments, completely insulated from the destructive heat of stars. This means that the outer ring is not merely a wasteland of dead ice, but a magnificent, solar system-wide storehouse of organic potential. waiting in silent suspension for billions of years. When these fragments leak into the inner system as comets, they distribute these intact chemical blueprints across space, revealing that the frozen wilderness holds the universal seeds of life. Deep within the mathematical foundations of the outer ring, subtle gravitational waves known as secular resonances quietly carve out empty lanes within the distribution of matter. These invisible forces do not operate through sudden, violent pushes, but rather through the slow, rhythmic alignment of planetary orbits over hundreds of millions of years. The long-term gravitational rhythm of the giant inner gas worlds, particularly the steady precession of the orbits of Neptune and Uranus, creates specific coordinates where energy is continuously transferred to smaller bodies. This cumulative interaction gradually increases the orbital tilts and elongations of any fragile ice world unfortunate enough to reside within these resonant zones, eventually destabilizing its path entirely. The resulting gaps serve as silent cosmic highways, clearing distinct spaces in the inner belt and directing displaced fragments onto pathways that may eventually lead them toward the inner solar system. Investigating these secular boundaries allows us to appreciate the intricate, invisible clockwork that slowly refines the structure of the outer dark, demonstrating that even the most distant orbits are bound to the collective pulse of the planetary family. As automated observatories accumulate more data on the faint signatures of these frozen worlds, a striking correlation has emerged between the structural tilt of an orbit and the true physical coloration of its surface. Objects that move within the quiet, flat midplane of the system exhibit a remarkably pure, ultra-red hue, indicating a pristine surface that has remained entirely undisturbed since the dawn of creation. Conversely, those worlds that travel along highly inclined, sweeping paths above and below the main disk display a far greater diversity of shades, ranging from neutral slate grays to soft, icy blues. This color-inclination relationship suggests that the dynamic events which tilted these orbits also exposed different internal layers of material, or brought together populations born in vastly different temperature zones of the early nebula. It reveals that the physical appearance of a world is deeply intertwined with its historical motion through space, allowing astronomers to read the ancient migrations of the outer system simply by mapping the changing colors of the dark. The largest and most dynamic testimony to the ancient abundance of this frozen wilderness is not found drifting freely in space, but rather trapped in a permanent backward orbit around the blue ice giant, Neptune. The massive moon Triton exhibits a unique retrograde path and a primitive, nitrogen-rich composition that strongly betrays its true origin as a displaced sovereign of the outer belt. Long ago, During the chaotic era of planetary migration, this colossal sphere of rock and volatile ice ventured too close to the expanding gravitational domain of the young gas giant. Instead of experiencing a violent collision or being thrown out into the interstellar void, Triton encountered a dense cloud of primordial material surrounding Neptune, which slowed its velocity just enough to allow the planet's gravity to ensnare it forever. Today, this captured Titan stands as a living museum of the Outer Ring's grandest scale of creation. Its active ice volcanoes and frozen plains, offering a magnificent close-up view of a primordial world that once ruled the deep dark as an independent king. When we ponder why some worlds in this freezing wasteland retain vast, reflective plains of volatile nitrogen, while smaller fragments are reduced to dark, charcoal crusts, we enter the delicate realm of planetary volatile retention models. The survival of highly volatile ices like methane, carbon monoxide, and nitrogen over billions of years depends on a precise mathematical balance between the surface gravity of a world and the absolute temperature of its environment. Massive dwarf planets possess just enough gravitational strength to hold onto these lightweight molecules, preventing them from slowly escaping into the vacuum of space through the gentle push of faint solar winds. Smaller fragments, lacking this necessary mass, suffer from a slow and continuous leakage where their volatile atmospheres evaporate into the void atom by atom over cosmic timescales, leaving behind only the heavier, unyielding water ice and dark carbon residues. This natural sorting mechanism creates a diverse cosmic landscape where only the true giants can preserve their brilliant, snowy mantles, while the lesser citizens are destined to wear the dark, weathered garments of time. Because the vast majority of these distant icy bodies appear as nothing more than faint, microscopic pinpricks of light, even to our most advanced space telescopes. Scientists must rely on the precise measurement of light curves to map their hidden physical attributes. As an irregularly shaped object rotates slowly in the dark, the total amount of surface area reflecting sunlight toward the Earth changes continuously, creating a rhythmic rise and fall in its recorded brightness. By analyzing these subtle, repeating variations over hours and days, astrophysicists can accurately deduce the rotation speed, the elongation of the body, and even the presence of large craters or differing chemical patches across its surface. This ingenious method turns a limitation of distance into a source of profound revelation, allowing us to visualize the detailed forms of worlds we cannot directly see. It reveals a silent wilderness populated by tumbling fragments, elongated stones, and complex binary pairs, all spinning to their own individual cadences in the deep outer dark. One of the most surprising phenomena observed in the twilight zone past the planets is the sudden, energetic awakening of short-period comets, long before they ever reach the warm embrace of the inner solar system. Traditional models suggested that comets should remain completely dormant until solar heat begins to melt their water ice near the orbit of Mars. Yet many travelers exhibit massive outbursts of gas and dust while still drifting in the extreme cold past Saturn. This premature activity is driven by a fascinating physical transition within the molecular structure of the ice itself, where ancient amorphous ice spontaneously reorganizes into a highly structured crystalline lattice. This structural rearrangement occurs at specific, ultra-cold temperatures and releases a significant amount of stored internal energy, triggering a rapid vaporization of volatile gases like carbon monoxide trapped within the frozen matrix. The resulting pressure shatters the surface crust, launching brilliant plumes of dust into space and demonstrating that the deep freeze holds its own internal mechanisms of sudden, explosive transformation. The profound crimson coloration that defines so many of the undisturbed residents of this distant ring is the product of a slow, eons-long chemical alchemy known as methane photolysis. On the surfaces of these cold worlds, simple methane molecules are constantly subjected to a gentle but relentless bombardment of ultraviolet starlight and high-energy galactic cosmic rays. This energetic input slowly breaks the chemical bonds of the simple gas, allowing the freed carbon and hydrogen atoms to recombine into much longer, more complex organic structures. Over millions of years, these chemical reactions transform the clean, translucent methane ice into a dense, tar-like substance composed of heavy macromolecules called tholins. This organic carpet acts as a natural protective shield, absorbing the energetic radiations of space and painting the outer system in the deep, rich colors of ancient rust. Deep within the structural core of the classical belt, planetary dynamicists have identified a highly specific subpopulation of icy bodies known as the kernel. This mysterious group consists of thousands of small objects that move along remarkably similar, tightly clustered circular paths that display almost zero orbital eccentricity or tilt. Unlike the rest of the classical family, which is slightly more spread out through space, the members of the kernel are packed into a precise, narrow band that appears entirely separate from its surroundings. Scientists hypothesize that this ultradense concentration of matter was created during a specific phase of Neptune's outward journey, when a temporary drop in the planet's migration speed caused its gravitational resonances to drop a large collection of objects in one single, specific location. The kernel stands as a pristine, unmoving snapshot of a single moment in cosmic history. A dense gathering of ancient survivors that have drifted side by side in perfect harmony for billions of years. navigating a robotic spacecraft through the immense, dark spaces of this outer wilderness presents an extraordinary engineering challenge that requires an absolute reliance on autonomous optical systems. At distances spanning billions of miles from Earth, radio signals take several hours to travel back and forth, making real-time control from human operators completely impossible. To find its way through the shadows, the onboard computers of the probe must continuously capture images of the surrounding void. Comparing the slow drift of nearby icy targets against the fixed, highly detailed patterns of millions of distant stars. This method of optical navigation allows the mechanical scout to calculate its exact position and trajectory with pinpoint accuracy, independent of any guidance from its home planet. It is a beautiful image of absolute self-reliance, a small spark of human intelligence steering itself through the permanent twilight of the outer ring solely by reading the eternal map of the galaxy. When we extend our awareness far into the unimaginably distant future of our solar system, we can catch a glimpse of the ultimate gravitational destiny that awaits this frozen ring of ancient matter. Billions of years from now, our sun will exhaust its nuclear fuel and expand into a roaring red giant, completely engulfing and destroying the rocky inner planets in a final display of stellar fury. However, the outer belt will easily survive this fiery epoch, its distant coordinates shielding it from the immediate thermal destruction that reclaims the inner worlds. As the sun eventually sheds its outer layers and collapses into a small, dense white dwarf star, its total mass will decrease by half, causing its gravitational grip on the outer system to weaken significantly. This drop in gravity will allow the remaining icy bodies to slowly drift further outward into the deep galaxy, dissolving the ancient ring and scattering its citizens into the infinite interstellar void as lonely, independent wanderers of the cosmos. Within the vast stretches of this outer dark, astronomers have discovered distinct groups of objects that share identical chemical signatures and orbital pathways, revealing the ancient scars of monumental cosmic collisions. When a massive impact occurs in this freezing environment, the low gravity allows the shattered fragments of the parent world to spread out across millions of miles, while still maintaining a collective trajectory around the distant sun. One famous family of fragments is coated in an incredibly pure layer of bright water ice, completely devoid of the dark organic materials that usually blanket their neighbors. By tracking these related wanderers, planetary scientists can reconstruct the exact size and speed of the ancient intruder that disrupted the original world billions of years ago. This discovery proves that the quiet wasteland has its own history of catastrophic events, leaving behind families of icy twins that drift side by side through the centuries, like fragments of a broken mirror. To decipher the true nature of these remote bodies, modern astrophysics relies heavily on the advanced capabilities of space telescopes that observe the universe in the infrared spectrum of light. While traditional telescopes only see the faint sunlight reflected off the frozen crusts, infrared sensors can detect the subtle, microscopic warmth that the objects radiate back into the cold vacuum of space. This delicate thermal emission allows scientists to separate the physical size of an object from the reflectivity of its surface, solving a major puzzle of the outer system. A small, brilliantly white world can reflect the same amount of sunlight as a massive, charcoal-dark fragment, making them indistinguishable in visible light. By measuring this hidden warmth, we gain an accurate map of the true dimensions of these silent wanderers, revealing a population that is far more diverse in size and structure than anyone had previously estimated. Deep within the mechanical order of the outer ring, a fascinating gravitational phenomenon continuously alters the paths of highly tilted objects through a slow exchange of orbital characteristics. Known to scientists as a secular geometric interaction, this process causes a distant body to slowly trade the steepness of its orbital tilt for the elongation of its orbital path over cycles lasting tens of millions of years. When the object's path becomes nearly flat and aligned with the planet's, its orbit stretches out into a long, eccentric loop that carries it far into the deep dark. As the cycle reverses, the path rounds out into a neat circle while tilting sharply above and below the main plane of the solar system. This beautiful cosmic seesaw keeps the fragile ice worlds in a state of perpetual dynamic balance, preventing them from venturing too close to the destructive gravity of Neptune, while constantly changing their perspective on the distant stars. When astronomers describe the different populations of this icy wilderness, using terms like hot and cold, they are referring to a profound concept known as dynamic temperature, rather than the physical chill of the ice. The cold classical citizens are dynamically quiet, moving along peaceful, circular paths that have remained completely undisturbed since the very birth of our star. The hot populations, conversely, possess a high dynamic temperature because their orbits are highly energetic, tilted at wild angles, and stretched into elongated paths that cross through different zones of space. This terminology allows astrophysicists to visualize the kinetic energy of the outer solar system as a fluid ecosystem, where calm pools of ancient matter exist right alongside turbulent streams of scattered fragments. Contemplating this distinction reveals that the icy wasteland is not a uniform desert, but a complex arena of contrasting movements where the echoes of ancient planetary migrations are still vividly alive. On the grandest worlds of this frozen domain, scientists have observed astonishing evidence of active geology that defies the extreme cold of the outer solar system. Deep within these massive spheres of rock and ice, the slow decay of radioactive elements generates a small but steady supply of internal heat that rises toward the surface over millions of years. This faint thermal energy is sufficient to cause vast sheets of solid nitrogen and methane ice to soften and slowly churn through a process of thermal convection. Images returned from space probes reveal vast, unblemished plains divided into large geometric cells, where fresh ice continuously rises from below to erase ancient impact craters. This slow, frozen respiration demonstrates that a world does not require the intense heat of a nearby star to remain geologically alive. Shifting our understanding of planetary dynamics into a realm of cold, quiet power. This monumental ring of frozen matter does not exist in absolute isolation from the rest of the galaxy, but acts as a grand outer gateway that interacts with travelers from interstellar space. Over cosmic timescales, independent fragments of rock and ice cast out from distant star systems drift across the infinite void and pass directly through the outer boundaries of our solar system. As these alien wanderers cross the threshold of the belt, their unique speeds and highly hyperbolic trajectories set them completely apart from our local icy citizens. Some of these interstellar visitors are briefly altered by the collective gravity of our outer worlds, their paths bent slightly as they glide silently past the native planetesimals. Observing these rare interlopers provides a breathtaking opportunity to compare the raw materials of our own nebula with the remnants of distant, alien suns, reminding us that our frozen frontier is merely a small harbor in a vast galactic ocean. The scientific analysis of short-period comets leaking out of this reservoir has provided a definitive method for tracing the ancient origins of the water that fills our oceans on Earth. By measuring the precise ratio of deuterium, a heavy form of hydrogen, to normal hydrogen within the cometary ice, researchers can create a unique chemical fingerprint for the outer ring. For decades, it was uncertain whether the water on our planet came from local rocky asteroids or from the frozen wilderness past Neptune. Recent space missions that analyzed the vapors of these returning comets discovered that their hydrogen ratios match the composition of Earth's modern oceans with remarkable precision. This realization establishes a profound physical link between our daily existence and the deepest dark of the outer system, suggesting that every drop of water that sustains life on our world was once locked in the absolute deep freeze of the cosmic suburbs. The surface features of the smaller fragments within this wilderness are continuously modified by a slow and gentle process of cosmic sandblasting caused by microscopic space dust. As tiny particles of rock and crystalline ice drift through the outer system at thousands of miles per hour, their impacts systematically erode the exposed crusts of the larger planetesimals. This relentless, low-energy bombardment slowly grinds down sharp ridges and fills in microscopic crevices, coating the objects in a fine, powdery layer of primitive regolith. This soft mantle acts as a natural insulator, protecting the volatile chemical secrets hidden deep within the interior from the fluctuating radiations of open space. The entire region can be understood as a masterfully sculpted landscape, where the chaotic movements of microscopic dust slowly smooth the contours of ancient ice worlds over billions of years of absolute silence. As astronomers map the trajectories of the most extreme and detached objects residing on the furthest edges of the scattered disk, they continue to find compelling mathematical patterns that point to a grand cosmic mystery. These lonely worlds travel along immensely stretched paths that require thousands of years to complete. Yet their closest approaches to the Sun all cluster within the same vast region of space. The laws of celestial mechanics suggest that such a precise alignment should naturally dissolve over time, unless a massive external force is actively maintaining their orientation. This enduring symmetry has led top researchers to calculate the potential properties of a major undiscovered planet lurking in the deep twilight. A world that would act as a silent gravitational shepherd for these distant fragments. Whether this hidden king truly exists or is a ghost of our past, the search itself continues to expand the borders of human knowledge, proving that the outer dark still holds secrets capable of redefining our cosmic map. When we imagine the perspective from our most distant robotic spacecraft as they drift through the heart of this frozen ring, we perceive a profound transition in the visual architecture of the cosmos. Looking back toward the center of our system, the magnificent gas giants have dissolved into tiny, faint points of light, entirely lost in the blinding glare of a sun that has shrunk to the size of a brilliant pinprick. The familiar constellations of the night sky remain perfectly unchanged, yet they appear with a piercing, unblemished clarity that is completely impossible to experience through the thick atmosphere of Earth. The spacecraft moves through this immense emptiness without any sound or sensation of speed. A silent metal monument floating among trillions of invisible ice worlds. This final frontier represents the absolute limits of human ingenuity, a place where our understanding of nature transitions into a realm of eternal stars and unhurried cosmic patience. As we reach the deep outer edges of this icy ring, we find that its furthest members exist in a profound transition zone where the magnetic domain of our sun begins to yield to the raw pressure of interstellar space. This boundary, where the solar wind slows down and collides with the cosmic gas of the galaxy, creates a shifting environment of intense radiation particles. The frozen fragments traveling through this region are continuously bombarded by cosmic rays from distant star systems, altering their outermost molecular layers over billions of years. This unique positioning makes the furthest line of the belt a true frontier, acting as a structural buffer between our local planetary family and the uncharted wilderness of the wider Milky Way. To observe these objects is to look at the absolute shoreline of our sun's immediate influence, where the light of home begins to blend into the eternal dark of the galaxy. It is a place of profound stillness, where the quiet rules of our local system dissolve into the grand, unmeasured rhythms of the interstellar void. Deep within the hidden interiors of these smaller, porous fragments lies a pristine vault of primordial chemical components that have remained completely untouched by external radiation. While the outer crusts are dark and weathered by eons of solar wind exposure, the deep core preserves delicate organic networks and ice structures exactly as they existed during the dawn of creation. These hidden reservoirs contain complex carbon compounds, amino acid precursors, and volatile gases trapped in a state of absolute suspended animation. This interior isolation protects the raw ingredients of life from the destructive heat of stars and the violent energies of space, preserving them for billions of years. When one of these fragments is nudged toward the inner system, it carries these pristine materials intact, serving as a cosmic delivery system that bridges the frozen void with the fertile environments of young planets. To contemplate these hidden cores is to realize that the raw materials of biology are preserved perfectly in the deepest freeze, waiting in silent patience for their moment of awakening. A fascinating structural contrast exists between the largest dwarf planets of this frozen ring and the countless smaller fragments that share their sweeping orbits. The massive worlds possess enough gravitational energy to have undergone internal differentiation, allowing heavier rocks to sink to their cores, while lighter volatile ices rose to form complex, active surfaces. These giant citizens can refresh their landscapes through slow convection and seasonal changes, creating bright plains of nitrogen frost. The smaller fragments, conversely, lack the mass required for such internal evolution, remaining as primitive aggregates of dust and ice that have never changed since their initial accumulation. This cosmic hierarchy creates a diverse landscape where geological kings rule over an endless sea of ancient, unevolved remnants, each telling a completely different chapter of our solar system's history. Watching these two distinct populations drift side by side highlights the beautiful variations that can emerge from the same fundamental building blocks of nature. The profound gravitational reach of the blue ice giant extends far beyond its immediate orbital track, trapping a unique family of outer fragments in a permanent celestial dance. These captured objects, known to astronomers as Neptune Trojans, reside within stable gravitational pockets that travel 60 degrees ahead of and behind the planet in its long journey around the sun. These secure zones act as cosmic sanctuaries, preserving a highly concentrated population of icy bodies that share the exact chemical signatures of the wider belt. Because their paths are permanently locked to the rhythm of the giant planet, they have escaped the chaotic scattering that cleared the surrounding lanes of space. Observing these Trojan companions provides a beautifully accessible window into the ancient composition of the outer ring, demonstrating how gravity can create islands of perfect stability within a shifting wilderness. When an icy wanderer is finally cast out of this frozen reservoir and directed into the inner solar system, its dynamic lifetime becomes limited to a brief cosmic moment. Caught in a turbulent gravitational network dominated by the immense mass of Jupiter, the displaced fragment faces a chaotic path that rarely lasts more than a few million years. With every close approach to the sun, the intense thermal energy strips away meters of its ancient ice mantle, systematically exhausting its volatile reserves. Eventually, the comet either disintegrates entirely under thermal stress, collides with a planetary body, or is thrown completely out into the interstellar void as a lonely exile. This continuous, destructive cycle highlights the transient nature of these spectacular visitors, showing that their brilliant displays of light are merely the final, fleeting chapters of a journey that began in the eternal quiet of the outer dark. It is a process that reminds us of the constant recycling of matter, where ancient ice is transformed into brilliant energy before returning to the silence. When we train our most advanced space observatories on distant star systems across the galaxy, we discover that our frozen outer ring is a universal feature of cosmic architecture. Astronomers have mapped massive, glowing rings of cold dust and icy, debris-encircling mature stars like Vega and Fomalhaut, mirroring the exact structure of our own outer belt. These alien structures represent the leftover ingredients of planetary formation occurring around distant suns, proving that the processes which built our home are repeated throughout the universe. By studying the slow dynamics and chemical compositions of our local ice worlds, we gain a direct understanding of how planetary systems grow, age, and evolve across the wider cosmos. This realization dissolves the sense of absolute isolation that defines the outer dark, connecting our lonely frontier to the grand, repeating patterns of galactic creation. the structural differences between the peaceful lanes of the classical belt and the wild trajectories of the scattered disk are vividly illustrated by the survival of binary pairs. Within the quiet midplane, where movements have remained gentle and circular for billions of years, a massive percentage of objects continue to travel in close companionships. However, within the scattered disk, where objects were violently thrown outward by the gravity of Neptune, these delicate twin systems are almost completely absent. The intense gravitational forces experienced during those ancient close flybys easily overcame the weak bonds linking the pairs, tearing them apart and sending them on independent paths through the void. The absence of twins in these outer territories serves as a clear historical record of ancient violence, proving that the chaotic migrations of the giant planets left a permanent mark on the social structure of the outer worlds. Among the larger and more mysterious worlds that inhabit this frozen wilderness, scientists have detected astonishing evidence of cold volcanic activity that challenges the traditional definitions of geology. This phenomenon, known as cryovolcanism, occurs when internal heat sources melt mixtures of water ice, ammonia, and methane deep beneath the frozen crust. The presence of ammonia acts as a natural chemical antifreeze, allowing the liquid slurry to remain fluid at temperatures far below the normal freezing point of pure water. When pressure mounts within the interior, this icy liquid erupts gently through fractures in the surface, flowing across the plains before instantly freezing solid under the cold starlight. This slow, frozen volcanism continuously reshapes the landscapes of the outer sovereigns, revealing that even in an environment of absolute chill, the elements can find ways to mimic the fiery dynamics of the inner planets. The modern Kuiper Belt exists in a state of slow and continuous dissipation, systematically losing its ancient mass over cosmic timescales through a variety of subtle mechanisms. In addition to the regular leakage of short-period comets into the inner system, the entire region is subjected to the gentle, eroding action of solar wind particles and intense ultraviolet light. This relentless cosmic weathering breaks down the surface ices into microscopic gases, which are slowly carried away into interstellar space by the outward pressure of the sun's radiation. Millions of tons of primitive matter evaporate into the void every single year, ensuring that the ring grows steadily thinner and more dispersed as the centuries march forward. In the unimaginably distant future of our stellar home, this slow-motion evaporation will eventually clear the outer spaces completely, leaving behind an absolute and unblemished vacuum where a grand ring of ice once turned. Our historic journey through this frozen outer wasteland culminates in the realization that these cold, distant targets represent the ultimate bridge to understanding the wider universe. The mechanical scouts and advanced space telescopes we deploy to map these dark coordinates are not merely studying local debris, but are capturing the pristine, unbaked blueprints of planetary creation. Every chemical ratio discovered, every binary orbit measured, and every frozen plane mapped brings us closer to unraveling the fundamental laws that govern the birth of star systems across the galaxy. As our technology continues to advance, we prepare to peer even deeper into the shadows, ready to uncover the smaller, fainter fragments that still hold the secrets of our origins. This ongoing quest transforms the icy wasteland from a lonely, forbidding desert into a source of infinite inspiration. A silent sanctuary of knowledge that invites human curiosity to expand into the eternal dark. Our long, drifting journey through the ancient avenues of the Kuiper Belt now slows, matching the stately and patient pace of the frozen worlds themselves. We have traversed billions of miles of empty space, moving past the blue majesty of Neptune into a domain where time operates on a grander, more majestic scale. Here, the raw blueprints of our planetary neighborhood remain perfectly locked in a perpetual deep freeze, acting as a pristine vault of memory from the very dawn of creation. The thousands of icy fragments, wide binary pairs, and massive crimson dwarf planets continue their silent, centuries-long orbits completely unhurried by the brief passages of human history. As we look back from this remote frontier, the intense energy of the inner planets dissolves into a distant whisper, leaving us enveloped in a profound and velvety quiet. The mind expands to find absolute comfort in this monumental scale of solitude, recognizing that the deepest darkness of space is not a void of loneliness, but a sanctuary of perfect, undisturbed order. Contemplating this frozen wasteland reminds us of the beautiful and delicate threads that bind our warm, vibrant planet to the absolute chill of the outer system. The luminous short-period comets that occasionally trace their brilliant paths across our night skies are gentle messengers from this very wilderness, carrying the ancient water and organic blueprints that once nurtured the conditions for life on Earth. Every drop of water that flows through our oceans and sustains our breath was once held in the frozen matrices of these distant planetesimals, drifting quietly under a sun reduced to a brilliant pinprick of light. There is a deep architectural elegance to a universe where the coldest, most isolated frontier serves as the ultimate cradle for planetary renewal and cosmic creation. As these frozen wanderers continue to leak slowly into the inner system or drift outward into the interstellar sea, they weave a continuous tapestry of movement that unites the entire cosmos into a single, living story. To understand the quiet patience of the outer dark is to understand our own deepest roots, finding a sense of belonging within the grand mechanical core of the stellar family. Now, the faint starlight catches the clean nitrogen frost of the outer, sovereigns one final time, as we allow our awareness to rest completely within the silence. The invisible lines of gravity continue their flawless, synchronized choreography, guiding every primitive stone, spongy fragment, and twin whirled through the eternal dark with absolute mathematical precision. The cosmic cliff drops away into an even deeper, more majestic stillness, preparing the way for the infinite star systems that rotate silently across the wider galaxy. There are no more questions to answer, no more distant horizons to map, only the steady and unhurried breathing of a cosmos that has endured for billions of years. Let the profound chill of the outer sanctuary insulate your thoughts, wrapping your awareness in a protective mantle of absolute serenity and unblemished peace. Sleep soundly under the watchful, eternal eyes of the distant stars, drifting effortlessly into a deep, tranquil, and beautiful rest.